Okay, in this video we are doing Calc Problem Set 126. The problems and a playlist are in the description below. Let's see what we're doing. Number 1, given the differential equation dy dx equals the quantity 18 minus y all over 5 with y of 0 equals 8. So that's what we're given. Write the equation of the line tangent to y equals f of x at x equals 0. Okay, so we're going to need to know the value of dy dx at x equals 0. But the differential equation is in terms of y, so really we need to know dy dx when y is equal to 8. And I've filled in 8 for y, so I have 18 minus 8 all over 5. That's 10 over 5, so 2. We know that we're dealing with y of 0 is equal to 8, so we're just going to plug in y minus 8 is 2, the quantity x minus 0. Don't get fooled by these problems. You have to really look at what variable you're dealing with, but as long as you know, you should be good. All right, B, find the particular solution to the differential equation with the given information. That just means solve the differential equation. So what I'm going to do in my first step is actually, I'm going to rearrange a little bit because I do not like to have a negative coefficient for y. So I will do this on every problem where there's a negative coefficient on the dependent variable if I'm doing separation of variables. I'm going to factor a negative out of everything on the right-hand side. So I have negative quantity y minus 18 over 5. I'm going to separate. I will leave negative 1/5 on the right-hand side. So I'll have dy over y minus 18 is negative 1/5 dx. I'm going to integrate both sides. So the left-hand side is a perfect natural log. It's going to be natural log absolute value y minus 18. The right-hand side is just reverse the power rule, I guess, or just what has a slope of negative 1/5, negative 1/5 x plus c. So plus c goes on the side with the independent variable, which in this case is x. Now I'm going to solve for c. No, I'm not, actually. If the dependent variable is inside a natural log, exponentiate before you solve for c. So I'm going to have y minus 18 is a new value of c, e to the negative 1/5 x. So I skipped a couple steps there. I have a lot of videos on solving separable differential equations. I highly recommend you check them out. It's a very useful skill. You're going to see it on the AP exam, almost certainly. Now we'll solve for c. So we know that y of 0 is 8. So y is equal to 8 and x is equal to 0. So we get 8 minus 18 is c e to the 0, which means that c is negative 10. We substitute. We have y minus 18 is negative 10 e to the negative 1/5 x. Then we should really solve for y. So I'm going to add 18 to both sides. Y is 18 minus 10 e to the negative 1/5 x. All right, I think the rest of these are also solving differential equations. Good practice. You really need to know how to do it. Separable is by far the most common that you will see. So find the particular solution, just means solve. Given dh dt, so h is the dependent variable and t is the independent variable, equals negative 3/5 square root of h. And you can see I kind of by hand changed this. It should be the same on the PDF. H of 8 is equal to 25. All right, separate and integrate. So step 1, separate. So bring the radical h over. So we have dh over radical h. Bring the dt to the other side. We're going to throw some integral signs on here. I am thinking of that as h to the negative 1/2. So plus 1 times the reciprocal gives me 2h to the 1/2, or 2 root h. The right-hand side is just negative 3/5 t plus c. I'm going to solve for c at this step because there's no natural logs involved. So we have this. So 2 root 25 is negative 3/5 times 8 plus c. I mean, it still doesn't work out all that nicely. So if we do this, we get 10 is negative 24 over 5 plus c, and that means that c is 74 over 5. All right, so plug that value in, and we have 2 root h equals negative 3/5 t plus 74 over 5. But this isn't good enough because what we need to do is we need to solve for h. So I'm going to divide everything by 2 to get this. I am now going to square both sides, and I'm just going to leave it. So we have this. H is the quantity negative 3t over 10 plus 37 over 5 squared. So that whole quantity squared. That's our answer. Let's take a look at the next problem. Find the particular solution. Given dy dx is 1/8 x, quantity y plus 4 squared with y equals f of x and f of negative 3 is 4. So just playing around with the notation there, I guess. This is a separable differential equation. Let us separate it. So I'm going to divide both sides. I'm going to bring the y plus 4 squared to the other side. I'm going to just write it as to the negative second, though. So I'm going to have quantity y plus 4 to the negative second dy is equal to 1/8 x dx. So I like to do, if I can do a little simplification, I'll do it immediately so that I don't have to deal with it later. On the left-hand side, I'm going to do plus 1 times the reciprocal. The chain rule is balanced out already because the derivative of y is just 1. So I will get negative 1 over y plus 4. And then just, this is going to be 1/16 x squared plus c. So on the left-hand side, I really got negative quantity y plus 4 to the negative first. But I just, took the wrote it with positive exponents. All right, we need to solve for c. I don't think there's going to be a better time. I like to solve as soon as possible. So we know f of negative 3 is 4, so y is 4 and x is negative 3. Negative 1/8 is going to be 9 over 16 plus c, which means that c is negative 11 over 16. So I'm going to sub that in and just write the right-hand side with a common denominator. Negative 1 over y plus 4 is x squared minus 11 all over 16. We need to solve for y. So what I'm going to do is I'm going to take reciprocals and I'm going to multiply both sides by negative 1. So what that'll do is give me y plus 4 and then negative 16 over x squared minus 11. Then I'm going to solve for f of x, right? So I'm just going to subtract 4 from both sides. And get f of x is negative 4 minus 16 over x squared minus 11. All right, good practice problem there. Let's take a look at one more. Find the particular solution given dh dt, I had to capitalize the h, that's why it's weird and handwritten, is negative 1 over 25 quantity h minus 64, where h of 0 is 80. Separate and integrate. That's really the number one strategy that we have for these. So I'm going to make it dh over h minus 64 is equal to negative 1 over 25 dt. So I always leave the constant on the right-hand side if I can, any constant multiples. Integrals. And then on the left-hand side, natural log, absolute value of h minus 64. That's like incredibly common to get when you're doing these problems. So be aware of that. And then negative 1/25 t. We are going to exponentiate before we solve for c because it saves us a lot of difficulties with that absolute value. So h minus 64 is ce to the negative 1 over 25 t. Now we know that h of 0 is 80. So 80 minus 64. And again, I mentioned earlier, make sure you keep track of what you're plugging in for what, right? So h of 0, so t is equal to 0 and h is equal to 80 at this point. So that's going to be 16. And then we solve for h. So I'm going to say h is 64 plus 1/16 e to the negative, 64 plus 16 e to the negative 1 over 25t. And that's it. So that's the entire problem set. I hope this was helpful and good luck.